All right, so we're back and we are going to go over some triangle dilations. And I'm going to do some constructions on Desmos. You're not going to be able to do them because I didn't put this slide in there for you, but the whole point is for you to kind of watch me go through it and then understand what the missing pieces are. Okay. And so, okay, right now, the very first thing is our jump start. And it says, given triangle RST is a scale drawing of ABC, therefore corresponding sides are proportional. Okay, so if it's a scale drawing of something, it's like like multiple, one of these is a multiple of the other. So if you had to choose which side matches with this side AB, which side do you think matches with AB? And then, so if you said RS, you're completely right. But here's why. So, what I look for is these arc marks here. You have 1 and 2 on either at the angles that are adjacent to this side. 1 and 2. So then here goes 1 and 2, right? So that has to match that. So then now you have this ratio, right? That from here to here, it's from 8 to 12. Sometimes people say 8 to 12, and then sometimes even go 8:12. I tend to use a fraction because that's the one that you are probably the most familiar with. And now that you know this proportion from 8 to 12, you can now set up a proportion for the other sides. So then I'm going to go over here to this orange side. Sorry, let's go orange here. Which one matches this side here? Which one matches BC? Which one matches BC? And hopefully you said TS. That makes sense because TS is it's between the 2 and the 3. So therefore it matches. So if now you can set up this proportion, right? So the proportion that you would set up here would be 8/12 is equal to 6 over, I don't know, right? So 6/x, x, right? And then you can solve this however you want. Some people cross multiply this. Some people multiply by the least common denominator. Some people look at how we can multiply to get from here to here. I will cross multiply because that's probably what you're most familiar with. So we get 8x is equal to 72. So 8x is equal to 72, which then implies that x has to be 9, right? So then this side here is 9 centimeters. Okay. And last but not least, to find that third side, let's see, this green side, who matches with this green side here, right? Who matches with this green side here? And you're like, oh, this green side here. And you're like, yes. And so then now we have 6 over something, right? So that's going to be the same proportion here. So I'm going to copy this. Oops. There you go. I'm going to copy this over here for green. I'm going to show you in green just so you can keep your colors coded. So 8/12 is still there. But now this 6 is on the big triangle. So he has to match up with the 12. So he goes down here. Oops. So we got x divided by 12. Or I guess I should use y or some other letter so we don't confuse you. So this right here is y. And why did I put a 12 here? So why did I put a 12? Because that's wrong. So why did I put a 6 on the denominator here? Because the 6 was part of the big triangle, the bigger triangle, right? And then I would do the same thing again. I would cross multiply, so I get 48 equals to 12y. And then we go again, and we get 4 equals to y. Ta-da! And we're done. So that's how you find the missing sides of that triangle. So make sure that you know how to do this. There's going to be a couple practice problems, either in the retrieval or ready, set, go. Just make sure you know how to do that. Okay. So today you'll be able to create similar figures by dilation giving the scale factor. Again, dilation means that you're either pinching your phone so that the image you're zooming out, or you're unpinching your phone. I don't know what to call that, but spreading your fingers apart so that you're zooming in, right? So you'll be able to prove a theorem about the midline of a triangle using dilations. And then how do you know if two geometric figures are similar? And then how do you know if two geometric figures are similar by dilation? And what intersecting characteristics of an image are produced by dilating a polygon centered at one of the vertices of the polygon? So these are all the things that you're going to know. Some of these are like, what are you talking about, Ms. Johnson? What is a polygon? I don't remember. A polygon just means many sides. Okay, so moving on. It says, given triangle ABC, use the point M, this point here, as the center of dilation with a scale factor of 3 to locate the new vertices of new triangle A prime, B prime, C prime. So what are they asking you to do here? So that you've never, I don't know, maybe you have done a dilation before, but I'm going to treat you as if you've never had a dilation before, done a dilation. Now, normally you're using a compass and a straight edge, but here, because we're online, we're going to use our virtual tools. So I copied these points here, and they basically want you to, like, here it goes, use M as the center of dilation with a scale factor of 3. Okay, so when they say M as the as the center of dilation, whenever I draw my lines, I'm going from M through the point. Does that make sense? Now, sometimes people use rays. I'm going to use a line because if we ever have to go in the, like, if it's a reflection or a rotation, it'll go behind there, which that's not the case today. So I'm just going to make sure. I'm going to start with A. So I don't know if you saw me, but I chose the line tool. I click on M. Oops, and I just need to undo that because I just did that. I click on M, and then I click on A. It'll all snap. I don't know if you see, but it kind of like snaps through if you're following me along. Okay. And it goes through there. Okay. And I'm going to do similar to C and B. But because this is this first one, I'm going to choose to make all of the ones for this one is going to be orange. Okay. So everything that I do to get A prime, which should be somewhere out here because it said with a factor of 3, is going to be in orange. So the next thing I need to do is grab a segment. So I'm just going to go from M to A. And Ms. Johnson, do I really need to do that? The answer is yes, because in a second, I'm going to use the compass tool. And whenever you use the compass tool, you need a segment. So I'm going to choose this segment right here. And now you see I have a circle. And now they want me to put the circle somewhere. So I'm going to start at M and I'm going to go to A. Okay. And then I'm going to repeat that process. I'm going to grab that same segment and I'm going to go all the way here. And then I'm going to do that same process and I'm going to do that here as many times as I need. Now, in this case, I only need a multiple of 3. So let's count our 3 sections. 1, 2, 3. So technically, I did not need this third circle. So I'm going to get rid of that third circle. Oh, what did I just did that. I just erased the whole thing. There it goes. Sorry. I meant to undo it. I just want to 1, 2, 3. I'm just going to erase that last circle here. So I'm going to hit backspace and there it goes. So this is 1, 2, 3. All right. So the other thing I want to do is I want to label these orange because I told you everything's going to be orange. So it'll stand out. So now this point here, this point orange, I'm going to label it orange and I'm going to label it A prime. Okay. So you're going to do the same thing. You're going to put a line. You're going to get the segment tool and you're going to repeat that process for A, B prime. If you see, this is the reason why it's a multiple of 3 because there's 1, 2, 3 here. So go ahead and think about what that would look like. You could do it on a piece of paper. You could do it on Desmos if you'd like. But I'm going to meet you back here and then we are going to continue. Okay, now that you've like seen the first one, I'm going to do the second one for you. So you continue to do the same thing, and then you go here, you make a line here, make a line here, and you just connect those 2 points. And just like before, I'm going to color code this just so you can see how all of them are coming out. And this one I'll use, I don't know, maybe green. So there's green, right? And so then you're going to make a segment because you got to go this way. And I'm just going to make it green again. Okay, so now that you have a radius, now you're going to go to more tools and you're going to click on compass, and then you're going to click on that radius that we just made, that segment, and we're going to count 3 radii. So here's 1, here's 2. So I'm going to click on it again, and that would be 3. So 1, 2, 3. So then we're going to make another point right here, and we're going to make him green because everything would be C prime, and label him C prime. Okay. Prime means apostrophe. That's how we call them in math. Okay. Then you're going to do the same thing with this last one. Nothing new here. I'm just going to make everything blue. Maybe not blue because the triangle is blue. So maybe I will make him, let's see what other colors I have. Let's make him red. Yeah, red would stand out. Okay. So then again, do the segment from M to B so that when I pull the compass, and then again, I want to make him red. When I pull that compass, right, it's going to be here, here, and then I'm going to go here, and then I'm going to do it again, here. So it goes 1, 2, 3. And so notice that third point right there, that is going to be my B prime. And that's it. Like that's all you're doing. And so you won't have to learn you won't actually have to make a construction, but the whole point of this, let's see if you can look at this triangle that we just made. So ACB, I guess we should have said, right? Let me hide this real quick. Okay, so that's your triangle. And if you look, let me do this one too, just so you could see, right? They're similar, right? It's like I zoomed out on them. Does that make sense? I zoomed out on them. If you can get rid of these circles, then you would see just those 2 triangles. And it almost looks like it's, going through a tunnel, if you want to think about that, right? Okay, so that's all you have to do. So there's that. Move forward real quick. So remember that they said use point M as a center of dilation with a scale factor of 3. So you should see M as the center of dilation. See how all the lines, the red one, the orange one, and the green one all go through point M. Okay, that's what they mean by center of dilation. The second part that you're looking at is that there's 3 parts to it, right? 1, 2, 3, right? That means it's a scale factor of 3, right? So this guy grew by 3 parts, this guy grew by 3 parts, and this guy grew by 3 parts, right? Okay, so they want you to do the same thing except for now use N, this guy here, as your center, and then make a scale factor of half, right? A scale factor of half, and then the new guy is called A prime, B prime, C prime. So you can imagine how we're going to do this, right? And really quickly, we're just going to do the same exact thing. I'm not going to color code this time because now you should be used to looking at it. If not, just try to it's almost like you want to zero everything else out and just focus on that. Oops, I didn't mean to do that. So let me just undo that really quick. I did not mean to put that there. Let's see. Okay, so again, you're going to make a segment from N to B, and then you're going to do a compass point. Okay, So now your compass point is interesting because this whole thing, see how it doesn't work because now your circle is off there. So now instead of doing a segment like this, one of the ways to do this, not all the ways, is to make a circle from here. Oops. Do I want to do that? That's not what I want to do. Hold on a second. Give me 1 second. Where's my little... Okay, I forgot that Desmos has this tool called midpoint. So what you do is you... Wait, hold on a second. I messed it up. Hold on. You click on midpoint. So I clicked on... So if you click midpoint, then you click on this segment right here. It tells you there's a point. So I'm going to click on that point right there. And I say, okay, now I have a point. So now if you look, this whole length is 2 units. So half of that would be right here. So this is where B would be, right? So I'm going to label him B double prime. Oops. And then we're going to do the same thing. We're going to make a point from N to C. And then we're going to use our midpoint tool. And then we're going to click on that point. And then we're going to do another segment from N to A. And again, we're going to use that same thing. So now I'm just going to go through and label everybody. So this is going to be called A double prime. And this is C double prime. Right. And so now if I, again, connect the dots for you, you'd see, oops, what am I doing? You'd see this triangle that is similar, right, to this one right here. And he should be half as big, right? Do you see that? Do you see that the length from A to C looks half the length of A double prime to C double prime is half the length of AC. All right, just moving on here. Okay, so a dilation is a transformation on the plane such that if O is the center of dilation and a non-zero number K is the scale factor, then P prime is the image of point P if, now I gotta go grab my notes because I did not write this down. Give me 1 second. Boom. Okay. So a dilation is a transformation of the plane such that O is the center of dilation and a non-zero number K is the scale factor. Then P prime is the image of P if O, P, and P prime. Oh, I'm reading the wrong one for my wrong notes here. Hold on a second. I thought I was on the right one and I'm not. Hold on, I'm confused. Give me a second. Let me go forward real quick. So label the vertices in two triangles you have created above the diagram. Based on this diagram, write several proportionality statements you believe are true. So here, okay, sorry, let's go back to this one. So dilation is a transformation on the plane such that if O is the center of the dilation and a non-zero number, then P prime is the image of P if. Now here's your if, right? So there's a couple of ifs. So if OP and P prime are collinear, so if, let me do it in math, OP and P prime are collinear, and get my and in here, and I'm going to squeeze this guy down in here because I don't have a lot of space. So and this is the bigger deal, that OP prime divided by OP equals K. Okay, so that's true. So you're just looking from, now look at this guy, right? So from center to this guy, or from this guy to this guy, there's a factor. So pretend this length was 20 divided by 10, that your scale factor was 2, or your scale factor was half, depending on which way you're going, right? 10 divided by 20 is half, or 20 divided by 10 is 2, right? Okay. So that's all they're saying. So if OP and P prime are collinear means they're all in a line, right? Okay, so that's that. All right. So it says label the vertices in the two triangles you created in the above. We did that. Based on this diagram, write several proportionality statements you believe are true. Now there's a lot of them. Okay, you should be writing a lot of proportionality statements. Okay, so let's look at a couple of these. We wrote one here, OP prime OP. Now you could do stuff from here when we went from big to small, or you could do stuff from here, from from whatever to bigger, right? And so there's a lot of proportions that you could write. One of them could be like this section here, MB over MB prime is equal to MA over MA prime. There's actually a lot of them. You could even do BC over B prime C prime. So I'm going to be looking for this section in Desmos, and I want to see which ones you guys came up with. There's a lot of them. Okay. All right. So let's see the next part. It says, first write and verify that your proportions are true by placing them side by side with your measurements and millimeters. And I'm not going to have you measure them, but I want you to write some proportions out. Okay. How did you set up your ratios? How do you know these ratios are equivalent? What parts of the diagram did you use? Can you say more about what ratio means? So again, ratio just means one part to another part, or a whole part to another part, right? And when you're doing these ratios, just make sure you're setting them up in the same order. Okay, number 3, it says, based on your work, under what conditions are the corresponding line segments in an image and its pre-image parallel after dilation? That is, what word best completes the statement? After a dilation, corresponding line segments and image and its pre-image are always, sometimes, or never parallel. What do you think? After a dilation, corresponding line segments in an image and its pre-image are parallel, are sometimes, always, or never. So here what I want you to look at is, if you look at this segment AC, they're asking, do you think it's always, sometimes, or never parallel to A double prime C double prime, or BC to B double prime C double prime? Are they always, sometimes, or never parallel? Okay. Okay. And your answer should have been dun, 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 C. always, right? They're always parallel. Look at all of those sections, right? That looks parallel to that. And then look at the bigger set. Don't they look parallel? A prime, B prime is parallel to AB. BC parallel to B prime, C prime. And then same goes here. Okay. Okay. It says give reasons for your answer. If you choose sometimes, be very clear. I'm going to let you fill that out. Again, you should be able to say why you think those are parallel. This one says given ABC triangle ABC, use point A as a center of dilation with a scale factor of 2. Locate the vertices of the new triangle. Okay, so given a triangle, use point A as the dilation with scale factor 2. Where are the so now your center of dilation is actually a vertex, right? So can you imagine what that would look like if I went like this and I said I took this length and I put it right here. I took this length and I put it right here, right? Okay. So I'm going to do that really quick. So I'm going to do the same thing, go through here, and then now I need a compass, that section here, right? And then I guess I didn't need that, huh? Let me see if I could do this. No, I do need that. Okay, so I put this guy here, right? So you see how this one intersects with this one. So we're going to put a point there. Oh, I should just use, it doesn't matter. Do you see our new triangle? So here's our original guy right here, right? And here's our other guy here, here, here. You guys all see that? Do you see the two triangles? I call them overlapping. Whenever I see overlapping triangles, my students always get confused. So definitely draw these two separately so you can see how they go. So let's see what they ask us to do. It says, and locate the two new vertices, which we did. So now let's just label them. Label this guy. He would label him C prime. And you would label this guy as B double prime. Right? And then we would, and that's it. That's all they wanted to know. All right, why B double prime? Sorry, B prime. Okay, next. It says, explain how the diagram you created above can be used with the following theorem. Now listen, the segment joining the midpoints of the two sides of a triangle is parallel to the third side and half the length. So the segment joining the two midpoints, is this really a midpoint? Can you convince yourself that this is a midpoint? Can you convince yourself that this is a midpoint? So number one, can you convince yourself that number one, this is a midpoint of this, and this is the midpoint, and you're like, yes, I can convince myself. So number one, it's parallel to B prime, C prime. Okay. And then the next part is that it's half the length of this, right? So B prime, C prime is also half the length of that. And you're like, yeah, that makes sense because you doubled it this way, so it would be half this way. Okay, so you guys should be convinced. And that's it. So I just wanted to go over your takeaways. Takeaways say, dun, 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 key relationships between an image and its pre-image. So let me just type these out for you guys so that you guys have them. So the image, sorry, these are my notes. The image and pre-image. So the image is what you make. The pre-image is what was there. That's why it's called pre. Are similar figures. If you don't remember what similar means, it means they're in proportion to each other, right? And then the next one is corresponding pairs of segments in the image and pre-image are proportional. Let me spell this right. And it says the scale factor. So the scale factor that defines the dilation is also the scale factor between the similar figures that result in that dilation. And lastly, corresponding pre-image and image lines and line segments are parallel. Following a dilation. Except for the case that you have when the lines pass through the center of dilation, right? All right, so that's that. I don't know if I have another one. Yes, I do. So a dilation is a transformation. This is what we wrote together. A dilation is a transformation of the plane such that O, if O is the center of dilation, a non-zero number K is a scale factor, then P prime is the image of point P. If O, P, and P are collinear, they're all in a line, and this proportion is true, right? And then lastly, a two-dimensional figure is similar to another if, okay, now this is the definition, right? So pay attention. So the second can be obtained from the first by a sequence of rotations, reflections, translations, and dilations. Okay. All right. So the rest of this you can now finish on your own. Hopefully this all makes sense. Let me know. Have a great day. Bye.